Now, our subject is power system 2, power transmission. Okay, in the last semester you completed PS1 power generation. Now we are in power system 2. Power system 2 contain 5 units of syllabus. First unit is that transmission line parameter. Second unit is performance of transmission line. Third unit is that transient. Fourth unit is that mechanical design of a electrical transmission systems. Fifth unit is cables underground. These are the 5 units of syllabus in this semester. Okay, now here a power system too means after generating the power, how to reach this generated power generating station to load center. These aspects you can see in the PPT slide. Power plant will generate the power. After generating this power, the generated voltage is 11 kV in India, 11 to 22 kV in India. In Canada, up to 35 kV, and in Australia, 25 kV will be there. In India, we are on 11 to 15 or 22 kV only. Most of the stations 11 only. If I transmit this 11 kV generated power load center to generating station to load center, the transmission efficiency is very low. So that low voltage transmission of bulk power is not economical. Based on that economics of operation, and that to improve the efficiency of the transmission efficiency of the transmission system, now we are using the step-up transformer as per the availability of power. That is, using step-up transformer, we can operate the 132 kV. Above 130, above 33 kV operation, we are calling the electrical transmission system. Below 33 kV, we are calling the electrical distribution system. Finally, the customer, we are giving single phase, three phase supply. That also you can see in the slide in the PPT. Okay, now here, as per the availability of power, we will connect to the 132 kV system, 220 kV system, 400 kV system, 500 kV system, 760. The worldwide, the different operating voltages are there, almost near to all the values. Now in India, the standard operating frequency is 50 Hertz, in US is 60 Hertz. Different nations following the different frequencies. Okay, everyone. And this power system, these are the basic function: power generation, transmission, distribution, utilization of power. Now you can see that generating station and step up various towers. Then how we reaching the generating station to power? Through wires only on the structure, through wires only, over a transmission system reaching the power. Or instead of wires, you can use the underground cables through overhead transmission system, less cost. If it is takes X rupees, and if the underground cable it will take 6X rupees, means that more cost, 6 times more cost the underground cabling system. So majority of the worldwide all the long run power transmission, they will use the overhead transmission system, where some unavoidable situations only, river crossing, national highway crossing, such places they will use this underground cable power transmission. Why it is a costly but low high load density areas? If there is no other option, means then we have to use the last list option, cabling system. But it is having good performance compared to other systems. Okay, now you see this slide. Slide is covers electrical power system. Now I am moving to the second one. Now, transmission and distribution system, now you can see that generating a station, that line diagrams, how you can make it here, power station, set of transformer, transmission line, substation, distribution line, supplementary equipment. Now here choice of voltage is very, very important. To which voltage we have to transmit generating station to load center. The choice of voltage is very, very important. Choice of voltage, voltage variations, voltage drop, reliability, loading capability, location and load growth. These are very, very important. Choice of system voltage, and while transferring the use amount of power generating station to load center, we have to select the higher operating voltage and the choice only. Okay, that is very, very important. Now you can see this one also, this slide, it will shows the very, very all the functions of power system. Now you can see that after generating the power station, whether it is a thermal station, nuclear station, idle power station, thermal power station, or a solar power station, wind, any power station, after generating this power is given to the power transformer. This power transformer step up to the 440 kV, 765 kV as per the availability of power, and this will reach to the load center. After reaching the load center, once again step down to the lower voltage through the distribution transformers, and then you finally it will reach to the power to the various types of load. The loads may be which consume the electrical energy is called load. Domestic purpose, and that is called residential load, commercial purpose, commercial load, hotel establishment, industrial load, municipal load, or these are the various load. Five types of load will be there. Means that generating station to power is finally reached to the end user customers only. Okay, these all are the man-made system only. Finally, here generating station to low that end user consumer, in between only we have to run the power there to here, means through overhead transmission system or underground cabling system. Two options will be there. This overhead transmission system is less cost compared to the underground cabling system as per the requirement of the situation, and we have to choose the overhead or underground cabling system and operate choice of the operating voltage. If you go to the high voltage operating voltage, more advantages. Okay. Now you can see this slide also very important. All the functions are saying that. Now electrical power system. Now the generating station. Now it will be there. Now you can see that major function of power transmission, central station, three-phase alternator. After that, step up transformer. After reaching the load center, again step down process. Okay. This is also electrical power system. One single line diagram of a power station and their symbols. By using also you can use the power system like the symbol represented. This is very important. If you go visit any thermal power station, idle power station, anything, you can see that layout diagram like that only. Suppose when you enter into the VJIT campus in the main gate, all the sign indication will be there: A block, D block, D block, S block. Means by seeing that diagram and you can enter to the unknown person or known person also. So they, suppose they want a examination and the parents are visiting to campus, means that diagram will show the entire structure of VJIT campus, where the which block will be there. Like that, any power station will show these functions, where the power transformer, where incoming feeders, outgoing feeders, CTs, PTs, all the structure is available. One line diagram or single line diagram is showing like that. Okay. This is easy to understand the system. Okay. Now, nowadays, our power system or smart power system. Nowadays, our power system is smart power system. Means that power generation, transmission, distribution, everything is controlled by smart control room. Smart control room. All of the smart control room. The earlier is that only this interfacing is not there. Nowadays, all it will be controlled by the manually or automatic. Okay, by using this SCADA, and we are using many functions automatically. Okay, you can see some control room pictures in the generating station, whether a thermal or nuclear, any generating station like that one. Now you can see the fuel spikes, monitoring of frequency, operating voltage, various in the substation or the generating station. Now the by showing the mimic diagrams will indicate the LED bulbs, and it will show the generation of the voltage and frequency, all this one. This all we can see the any power station in the worldwide they are following these practices. Now you can see this here also the system operating frequency, but here we are saying that 58 frequency, but on 4-5 regional grids will be there. Each regional grid operating their independent frequency only. If you connect one frequency to the other, one regional grid to other grid, both the frequencies are same, then it is okay. Otherwise, both will go to the out of order. So to avoid such things, by using the HVDC Thailand, we are connecting asynchronous mode to synchronous mode of operation also. Now you can see that generation of voltage and that frequency also. Okay, these are all are the functions of a control room. power station. Yes, now we are seeing that original picture of our power system too. No component of a transmission line. This is the main. You observe this many names are there here. This structure will be, you can see the typical transmission line structure, cover, insulator, conductors, dampers, trusses, earthwine, spacer. This is the original structure of the HVDC tower. Now you can see the various components. This tower. Tower is made by the steel only. Steel, 1 kg of steel is 150 rupees to 60 rupees. That we are using by after construction of steel. After they will do the zinc galvanization. Why? Because the lifespan of that structure 40 to 50 years without any corrosion and good environmental conditions. They will do the galvanizing of the structures. So it will, the white coating will be there, and more number of years it will work without any deterioration of the structure. We have to see the lifespan is 40 to 50 years. Okay, you nearby any structure, you go see that white color is galvanized structure. Okay. Now, towers, insulators, conductors means that if you are transferring the huge amount of power generated into load center, your basic infrastructure is that use the quality structures means the towers and quality insulators, quality conductors, then you will get the transmission efficiency. Even required level 99.99% also possible, but we are getting 30% losses
Sir,
in the
English.
system is bad. Yes. Bad quality of structures, bad quality of insulator, bad quality of conductors, bad quality of not using the proper ground clearance. These are the causes for decreasing the transmission efficiency. By maintaining good quality infrastructure, definitely we can reach the above 95% of the. Why? Because there is no rotating parts, all of the static, only losses will be I square R losses. By operating higher
Sir,
voltage, I will be reduced less. Yes?
your
Yes?
voice is not
Anybody?
hearing, sir.
My voice is not hearing. Why? That is not. Yes.
Volume is not good.
Volume. Okay, now I raised. Earlier I asked many people, they said that hearing. My voice is clear. Now, okay, 90-30? 90-30?
Okay, sir.
Thank you. Very good. This is a component of a component of a transmission line. Now we will go to the next slide, and that is HVAC, HVDC. Today I am explaining all 5 units. One more important PPT is available. That's why I am telling that overall. Once again, after get back is 6 days gap is came to create some interest on PS2. Once again, I am giving the application to point of view this. Okay, now the power transmission power transmission from generating station to load center, we can transmit the AC transmission line or DC transmission line. 90% of our lines are HVAC lines only. Only 10% of lines HVDC lines. We can use AC transmission or DC transmission. It is having some little bit of the application here. The break-even distance for AC and DC. Below 500 kilometers of transmission is AC is economical. Above 500 kilometer transmission of power is DC is economical. Why? Because the DC system is required either side inverter and converter. In case of AC transmission, we need more number of step-up or step-down transformer only. In a DC transmission system, only 2 conductors and there is no skin effect, corona, all many problems will be arises. That is equal to R. Only positive conductor and negative conductors and 2 conductors. In case of AC transmission, 3-phase system is popular one, RYB, AC, RYB, 3 conductors are required. This below 500 kilometers, HVAC is economical, above 500 kilometers, DC is economical. Okay, these are the basic difference between AC transmission or DC. In coming days, more number of DC transmission lines are using. Why? Because cost effectiveness is good and stability also good, and you can operate one region to the other region. If the 2 dissimilar frequency systems are, you can connect asynchronous mode to synchronous mode is possible easily. These are some advantages of their HVDC transmission. Anyway, this paper will come you on 3.1 or 3.2 level. Okay, no problem. Just a little bit of introduction.
Now, HVAC and HVDC. Now you can see that worldwide various trends they are following. Suppose here 6,300 megawatts of power is there. They are using 3 into 8 kV lines, 3 lines they are operating here. Now here using AC or DC. Now you can use 3 into 800 kV in AC transmission. Same you can use 2 into 600 kV in DC. Means that which one is economical, then you can choose. Okay, if which one, anything is only economics only, economics, technical performance, reliability. By comparing these three fuses, AC is good, you can follow AC. If DC is good, you can follow. Finally, we need the less cost of transmission, less cost of transmission by using the AC transmission, DC transmission. Worldwide, all the nations, they are following different techniques. But more or less all the techniques are equal, and whatever the new technology will come within 5 years, it will spread to the entire the world. Okay. Now you can see that various towers and their techniques used. Okay. Now application of AC transmission, DC transmission, long distance bulk power, sea and land, the land cable transmission, asynchronous interconnection, power flow, congestion relief. These are the advantages of HVDC transmission. Okay, for HVAC or HVDC, these are them. Okay. Now ratings, power rating 400 megawatts, 500 kV plus or minus. This is DC. For 4,005 megawatts plus or minus 500 kV is. Now voltage ranges is plus or minus 500 kV for the 2009 operation. This, not only India, this worldwide trends they are following. Power ranges from 6,400 megawatts plus or minus 800 kV. These are various DC techniques we are using. Okay, AC or DC. Now, while coming to our first unit, transmission line parameters. In the transmission line parameters, we have seen that conductor, how you will choose the right conductor to transmit the bulk amount of power generating station to load center. That conductor having high conductivity, high mechanical strength. You can see the many conductors are there in this list: argon copper, cadmium copper, steel cord copper, and copper welded conductor, aluminum, all aluminum conductor, argon aluminum, all aluminum conductor, all aluminum alloy conductor, aluminum conductor, steel reinforced, ACSR, ACCC. These are the various types of the conductors we are using the transmission systems. So now you can see the practically all the types of conductor, bunch of you can remember okay, these are all the types of conductor, power line conductors. Okay, you can see these conductors. Okay. Now, power line conductor, we have to see that any conductor, some important properties, less cost, long life, brittle, weight, low resistance, low power loss, high tensile strength, low specific gravity, temperature coefficient. If it is negative temperature coefficient, it is good, but all are positive only. Shorter short. These are the required the quality of a good conducting material. Okay. Now, economic voltage for the transmission of voltage. This is very, very important. All of you observe this slide. Now, economic voltage for transmission of bulk power. Now, you can see this table. Suppose power transfer rating 3,500 megawatts, so 500 kilometer distance. Then you will choose the better option is 765 kV transmission. Suppose 500 megawatts and 400 kilometers, 400 kV or 440, 420 kV they will choose. 120 megawatts, only 150 kilometers they will choose 220 kV. Now 80 kilowatts and 50 kilometer distance 132 kV. Based on that distance and availability of power, we will choose the operating voltage. For example, in Nagarjuna Sagar to Hyderabad, what is distance? 144 kilometers. Now it is come under which category? 120. Now in Nagarjuna Sagar is available. That power is only 3 to 4 months, or during that rain season only 30 days or 45 days that surplus water is available, they will generate power. Only 220 kV lines is connected to load center Nagarjuna Sagar to Hyderabad. Okay, that one line will carry that 220 kV lines are, they will use, you can 150 megawatts. If 2 lines means 300 megawatts, 4 lines means 450 megawatts. Like that they will connect, okay, as per the availability of power. Now you can see this column is power, distance, operating voltage, choice of voltage. This is very, very important. Suppose in your house, your mother also, suppose you want only 2 members, they will use half liter rice bowl, and 4 members 1 liter rice bowl, and more than 4 2-liter bowl. If it is 10-20 members, she will get that bowls from the tent house or some other renter purpose for any occasionally function. Like that, as per your requirement, you are changing the bowl, and the rice requirement is more, means like that. Yes, as per the availability of power, distance, operating voltage will be fixed. Okay, choice of voltage, you can see that formula E is equal to 5.5 root of L by 1.6 plus KVA by 150. This is the transmission voltage line to line, and distance of transmission line, KVA, power to be transferred. This formula will use. Choice of voltage for transmission of power. Okay, this one. Now, while coming to the second, this slide, skin effect. I told that many times. Skin effect means that tendency of alternating current to flow on the surface of the conductor is called skin effect. This skin effect will be there in AC system. In DC system, so Z is equal to R. That entire conductor, the flow of electrons current will take place all the conductor. In case of AC, only outer conductor only having more density, and middle is no electrons. Okay, this is a property of material. This skin effect will be more in the AC high voltage transmission. This also linked with the frequency. So current depth, suppose current depth 500 kHz, how the skin effect will be there, you can see 5 kilohertz more, and current 5 kilohertz, 500 kilohertz, 500 hertz, 5 kilohertz, 500 kilohertz. Now it will change the corona effect. You can see through the graph. Okay, the effect of corona on the transmission of bulk power, frequency, and diameter of the conductor, permeability, type of material, shape of the conductor. This will influence the skin effect. Okay. Now, power line conductors, aluminum conductors, steel reinforced. You can see that outer conductors are made of aluminum, and centrally we are having the mechanical strength point of, we will use the odd materials, steel, like that. This any material which must having the excellent conductivity, low weight, and low cost. These are the basic requirement of any conductor. Now you can see that this relationship between the number of stranded on that one. This is also very important. 1 plus N plus into N, 1 plus N. N is equal to number of layers, total diameter of the conductor. This relation also very, very important. And after the class, if you want, I will send this PP to your groups, both the groups, as per your requirement. Now, next slide, you can see here power line conductors. How the real time you can see that whenever time permits, wherever the available the big structures, you can see the structures and the conductors. That all the conductors now you can see in this slide clearly all the different types of current carrying conductors, how it is manufactured, how the physical you can see here. So hollow conductors or the power line conductors is like that in the shape. Why? Because it is having long spans for 1 kilometer, 3 poles only. You want to use the high mechanical strength, high conductivity. You have to balance these features. Low cost, high conductivity, and less weight. These 3 features we have to satisfy the power line current carrying conductors. Then only you will get the higher transmission efficiency. You can clearly see all the power line conductors in this slide. Then I will go to next slide. Yes. Vibration on conductor. Suppose due to weather conditions, rainy season, winter season, summer season, some vibration will be there on conductor. These vibrations also unavoidable. So how to minimize the vibration means by connecting the ball loppings and spacers and the dampers. The transmission lines are arranged in multi-conductors for phase. Wind-induced vibrations, low frequency, high frequency oscillation caused by Steady wind. Suppose my house, I am observing that whenever that high wind velocity came, that wind will enter into the house. My house is already all the floors are false ceiling is done. When the outside wind will come, the fan rod is little gap is there, false ceiling, and it will touch, and outside wind velocity will disturb. It will create some noise. Immediately we will close the doors, then that noise may not appear. Means that vibrations are outside, high wind velocity will disturb the fan original, that rotating system. So that outside wind and the internal wind both will cross, and that false ceiling will, that vibration of rod, it will get a lot of noise. So like that, for that outside some rainy season and winter season and different seasons, it is having many that vibrations, wind induced vibrations are, that also we have to minimize. Low frequency, high altitude oscillations caused by the steady wind. Now we'll go to next slide. Yes, vibration on conductor. Now you can see that that how it will scanners and dampers will use to minimize the conductor vibrations. Vibration on conductor. A device cut down the cable and moderate wind and stop the conductors from the hitting another strong winds. Obviously, the conductor fit bridge must all in carry the same supply. Why? Because it is a costly system. The transmission structures, once you are erected, means the lifespan is 40 to 50 years. So, for that we have to use the many conditions and controlling the vibrations on that one, that to minimize the disturbances in the transmission system. These all are very, very important. Designing of a good transmission system, this transmission line parameters will place an important role on the transmission performance. Now vibration and conductors, how we will fix all this, and you can see the slide. Now these also you can see how they will fix big conductors in the carrying above the ground 40 meters or 20 meters is a big risk. Okay. Now loading transmission line supports loading. Now that various types of structures will be there. You can use the functional requirement, voltage, number of circuit, type of conductor, type of insulator, user addition of new circuit, tracing of transmission line, selection of tower site, selection of rigid points, and selection of height for each tower. Okay, these are the requirements of a transmission line support. We can use the ordinary wooden pole, concrete poles, various types. That you can see the next slide. Yes, these are the various possible of the transmission supports. As per the operating voltage and the distance and between the span, we will use the various types of the supports worldwide all the transmission systems. Okay. Clearance is less than 66, 20 feet, 66, 21 feet, and 132 feet, 22 feet, and greater than 220 kV and 7 meters. These are the clearances following plus or minus almost worldwide they are using same technique. Yes, now, okay, these various types of the line support. Olden days we are using timber based. Nowadays we are using concrete and steel poles only. Okay. Now you can see these types of poles and wooden poles that reinforced poles and various types of the poles as you can see here. Now you can see that the various different types of poles in the system, big structures. Now the structure is carrying 1, 2, 3. The bundled conductor and the 2 lines here will be the top one is the earth wire. So different types of the transmission system. Why? Because we have to use the transmission structures maximum capacity. Why? Because the construction cost is very high. We have to use the multiple lines and without losing the structure strength, and we can use the more number of lines. Okay, you can use the various structures and their vibrations, all you can see here, line supports. Yes, these are the transmission line supports. You can see that height of the transmission one, and H1, H2, H3. H1 is the minimum permissible ground clearance. H2 is maximum sag. H3 is vertical spacing between the conductors. Vertical clearance between the earthwire and the top conductor. This you can see here. Okay. Now, while coming to transmission line structures, okay, transmission line supports how it will use the ground clearance here for spacers and the clearance between the ground clearance. That also we are having one imperial formula. Based on that, you can decide. Now, clearance for the power line crossings. Clearance for the power line crossing means that we are using some imperial formulas. This spacing between the conductor phases. Okay. Yes, you can see here various types of vertical spacings and horizontal spacing. This various voltages. This technique used in the worldwide. Now you can see the 220 kV line spacing and the various spacings and their a type of structure use single circuit and double circuit, single circuit 500 kV circuit. Like that various circuits is operating. That is, this it shows that this one is horizontal spacing and this vertical spacing. This is given for the various values. Now, transmission line support. It is a transmission line support. It is having a single circuit or double circuit, length of the insulator assembly depends on minimum clearance of the lowest conductor above the ground clearance that we have seen in the above slide. These are the various structure and you can see that ground clearance, all the structures, various structures. This is also very one asked how to select a good structure. More mechanical strength, to withstand the all weather conditions and the designing of structures and the designing of line, whether it is AC line or DC line. Why? Because if it is used less space occupied structure is very good. Why? Because entire the space you are occupying the poles means you are occupying the more space means how can you get the food grains, all this one. We have to use less space for transmission of structures. Remaining space we have to utilize for the agriculture purpose, other activities. All the places occupied by the electrical poles means you can shortage of land will occur. So by applying the properly right of way and we have to minimize the power transmission losses and land usage of the also. Okay, these are the various structures of the line supports. How the 400 kV line is there, this you can see here. These are the transmission line structures, various. Now economic voltage for transmission, I have shown that in this slide already shown. Ice and wind loading means for some areas, suppose that Jammu and Kashmir, Himachal Pradesh, now all European countries, they are facing this minus temperature and ice loading on this effect, this will be there. They have to consider the many factors and then only you can do better transmission system. Transmission line. Now we are coming to this is very, very important transmission line insulator. How to select the bed good insulator means that a strain, various types of insulator and a strain type of insulator support generally along the shape of the, you can see here practically various types of insulator. You can see pin type insulator, the suspension type insulator and strain type, cycle type. These are very, very important. In the coming days, that operating voltage is always increasing only. We have to use the new type of insulating material to get the good proper, to get the better properties. Now you can see here all the various types of insulators used in the substation, all the places. Now these are the transmission line insulator, pin type insulator, suspension type insulator, strain type, cycle type, all these type of insulator. Now this is the cross-sectional view of a conductor. Why? Now we are, while carrying the overhead transmission line by using the good high-quality insulator at any cost, that structure is a steel. If you touch the wire means that leakage current will and power loss will take place. We have to use high-quality insulator and to carry the power safely to generating station to load center with minimum losses. In that point of view, how do you see quality insulator? Now with the cross-section of the insulator, you can see that yeah, how actually inside the insulator will be there. Now you can see the red one is the tensile forces and green is composite forces. How it will act on the insulator, how it will work. These are the transmission line supports, various types of transmission line. That string of insulator you can see here. Sometimes that girls will vary for years, many rings like that here. Suspension type of insulator will be there. More rings means higher operating voltage like that. This ring, this string efficiency, all the voltage distribution. Anyway, we'll discuss on this fourth unit. Okay, these are the strings and the string efficiency. How the voltage distribution takes place across the various insulators. Now here you can see here various types of insulator diagrams and now here insulator diagrams, their cross-sectional views and all this one. These various transmission line insulator, their operating systems and parameters. Now we will see this line, underground power transmission. Suppose now overhead transmission system is more economical and easy to transmit the bulk amount of power by underground cabling system. Means that whatever the money we are spending for overhead transmission, we have to use this 6 times more. Suppose it is 1 kilometer, 1 lakh means suppose it will take 6 lakhs. It is 1 crore means it is 6 crores. Means costly affair, but it is safe one and illegal that power losses will be minimized. Only in case of fault, identification of fault is difficult, but by using nowadays this information technology, underground cable transmission of power, you can easily identify the fault identification. Many things will be there. At the economics point of view, costly, but safe system only. Okay? Underground cable, you can see that how the cables will be laid down in the ground, with various. You can see here, okay, this laying of cables, all this one, how the multi-core cable will be there. Underground cables, okay, you can see these underground cables. Underground cables means that underground cables have the several advantages, better general appearance, and now in your house also we are using, is there anywhere cable is appearing? Early days in your old houses you can see that fleet wiring will be there, they will use wooden sticks and on that one only they will run wires. All are appear in the surface of the walls only. But nowadays we are using the concealed wiring, nowhere you are not here appearing any, only points only appearing, tube light, lamp holder and only points only. Remaining all are the concealed wiring. Appearance is good. But early days and in this, they are used the cleat wiring and everything is appear. But it is good for workshop, all this one physically you can see. That appearance point of view in the all commercial and domestic wiring, we are using this cleat wiring, conduit wiring. Okay, better general appearance and less liable to the damage to the terms of lighting and low maintenance cost, less chance of fault, small voltage drop. Disadvantages, installation problems, greater installation cost. Cost is very high. Okay. Now you can see that any under table is that many types of insulations will be there. Now servicing, armoring, bedding, lead sheet and conductor. In this way, 3-4 level of insulation will be there to protect the ground for providing more mechanical strength. Why? Knowingly, unknowingly, anybody dig the ground and it will get some various level of protection will be given. Okay, these are the underground cabling construction techniques. Now, okay, underground cables. Okay. Anyway, this we will see in the fifth unit. Properties of a insulating material, high resistivity, high dielectricity, high thermal strength, low water absorption, low permeability, non-inflammable, chemical stability, high mechanical. These are the required a good cable, okay, insulating material having these are the ideal properties to get the yes, types of material used for the insulations, rubber, vulcanized Indian rubber, and the impregnated paper, silk and cotton, enamel, Insulation, polyvinyl chloride, these are the varnished cambric. These are the 7 types of material used for insulation for underground cables. Insulating materials for cables is also, okay. You can see the some more slides here. Various types of the advanced cables. Cross-linked polyethylene. These are the advanced cables of cross-linked polyethylene cables. The material has temperature ranges 250 to 300 centigrade. The material good insulating properties. Okay, it depends on the special application we will use. The cables permit the conductor temperature 90 centigrade, 250 centigrade under normal and short circuit conditions. Okay, you can see that various cables and operating voltage, oil-filled cables, different types of cables. You can see that H type of cables and SL type of cables and the underground cables, oil-filled cables, different types of cables we are using in the transmission of bulk power generating station to load center. Now you can see the long slides in the slides and various laying of underground cables, how is the laying and to get the better performance of the transmission of bulk power generating station to load center. Suppose this New York City no overhead lines. Suppose New York City no overhead lines 1890 onwards. There is their economy is good. Singapore is 100% underground only. Netherlands distribution 100% is underground. So these are the financially well settled good countries and strong economy. They are implementing. So in India, if you want to implement all are underground, at least they have to implement in Hyderabad, Chennai, Bangalore, all 5 metronity. It is a costly affair. We need huge amount of funds, mobilization is required. So that Denmark also replaced 132 kV lines. These are the worldwide they are using the underground cables with the strong economic countries they are using. France, December 1990 has caused many blackouts, new policy, 25% HV lines are used. So these blackouts are very disturbance to the transmission of bulk power. Okay, a few years back that Suez that Egypt some canal is blocked. 80% of the world transportation is disturbed. Like that, we are transferring the bulk power from generating load center. If this national highways will be there, the transportation like that, this power transmission line also sometimes the failure will take the grid failure or it will disturb the entire nation or the southern states or northern state, eastern state, western states. Means that we have to avoid the blackout. Means better to use the 25% of the more lines are from underground cable, even though costly, and we have to raise the more number of underground cabling systems in the abnormal condition time, secured one only. Suppose, for example, you can see that December 1990 in sponsor caused many blackouts in France. They have converted more number of lines, Okay. Now you can see some more lines, some more diameters here, underground cables they are operating, and now you can see the underground cables wherever you want the cables or the lines, how your structures, you can see this one. This various types of overhead transmission lines, wherever national highways crossing will be there, we have to use the high quality grounds. These are the many lines will be there, underground cabling lines, and this you can see the various types of structures, insulators. This is how it will carry the different of lines of power, and this 33 kV line, 132 kV line, 440 kV line. This all this center the line you can see these are the underground cabling line. They are used the boxes whenever problem is very open. So your appearance is good. We are running the cables here ground. Okay. Whenever problem will arise, you open that box and you can clear the faults and you can easily clear. These are also passage of the underground cables in various cities in the worldwide, how they are planning that one without any 4 tons. These are underground cabling areas. How it is working is good and easy operate. Suppose in India also during the January month and many states they will use the kites and many children are died, this short circuits and all this one. There these overhead systems knowingly unknowingly they are touching the wires and many people are died. So better to convert to high population density underground cable is easy to operate and looking is good but costly affair. These are the various components in the substation. You can see the various components. Distribution transformer, all the places of various components, lighting arrestor, incoming feeders, outgoing feeders, and you can see the clearly oil circuit breakers and voltage regulators and control panels. You can see the diagram. Okay, these are the substations, and now we will see some more slides. These underground cablings and underground cables and underground cables and the various types of cables, how it will operate. These are the structures and this one. Parallel connected power systems, one system to other system, and then parallel connected power system. So all the generating stations are connected to the parallel operating systems, and then it is connected to the and the exchange of power is possible by use of the parallel connected system. HVDC, I told that many advantages are there compared to the break-even distance. I told that 500 kilometers. Okay, application of the exchange. These are the submarine applications also. We are using this underground cable, this cable supply, and in that case, overhead transmission lines are difficult. We use the underground cables for the submarine applications and this navigation application. We use the underground cables to transmit the huge amount of power efficiently for the navigation and submarine application and different applications. We use the big cables. Now you can see this layout diagram of HVDC station, and these are the interconnect conductors, various types of conductors, power system plant.